Good afternoon, everybody, and welcome to the second in a series of 4 webinars from the Interreg Heater Project. My name is Nick Timmins, and I'll be your host today. We have an hour-long webinar with 3 very interesting speakers. I just want to give you a little bit of background on the Heater Project. This is an MPA Interreg cluster project. It's a short 1-year project and brings together 5 longer existing projects in sustainability and energy in the MPA Interreg. These projects are either completed or just about to complete, and these are Handy Heat, Smart Renew, Tech Solutions, Sendoc, and E-Lighthouse. And the partnership is ourselves with the Smart Renew project. That's the Atlantic Technological University, formerly Letterkenny Institute of Technology, Ulster University, Oulu University of Applied Sciences, and the Northern Ireland Housing Executive. So the aim here really was with this clustering project is to maximize and collaborate our transnational outputs from our existing projects and push these out and these solutions and these ideas to local communities and decision makers through a sustainable enduring network, really with the aim to virtually educate and empower communities and decision makers. The title of this, the Heater, actually stands for Heat and Energy Education and Empowerment for Rural Areas. So that's really the topic here today. So this is the second in our series of webinars, and the webinar really is the main tool that we're using in this project to disseminate this information. So this webinar is entitled Remote Energy Monitoring for Sustainable Communities. I'm just going to share my screen here, just to give you a little agenda. So our first speaker today is Malachy McElholm from the School of Computing. And then at 3:20, we have Jean-Nicolas from University of Oulu, followed by 13:35 approximately, Shane Elliott from the Northern Ireland Housing Executive. We will have hopefully a question and answer session in the last 15 minutes, and then we'll finish off sharp at 2 o'clock. So it's a 1 hour in duration. For questions and answers, for questions, put them into the Q&A box, please, and then we'll go through the questions and our panel will come up with their answers. So I'm just going to introduce the first speaker. This is Malachy McElholm. He is a lecturer in electrical and electronic engineering in the School of Computing, Engineering and Intelligence Systems at the University of Ulster. He's currently involved in collaborative R&D projects with industry partners in the Agri food sector, developing energy monitoring, optimization solutions for dairy farms. Previously, he's worked on other projects such as the Enterprise Ireland funded Tempo project, which is an energy project, and he's also worked on the Interreg funded Epicenter project, which we also were involved in. And Malachy is currently working towards his PhD, which focuses on brain-inspired fault detection techniques to network and chips architectures, and thus developing fault-tolerant bio-inspired hardware. So Malachy, if you can share your screen, and I'll let you go. Thank you.
Okay, thank you, Nick. Can everybody see that?
Yep.
Okay, great. So again, my name is Malachy McElholm. I'm in the School of Computing, Engineering and Intelligence Systems here in the McGee campus in Derry, and I'm here to talk about energy monitoring, visualization and optimization in dairy farming community. And I'll talk later about the project partners that you see along the bottom there of the slide. Okay, but first, talk about the team at UU. So it's myself and Dr. Jim Harkin is the PA in the project. Dr. Ryan Beveridge then was the RA. He's involved in the day-to-day research and development on the project. And then Dr. James McGreer was brought in as an external consultant on the project, and as it was an important link between ourselves, the other stakeholders, and obviously the farmers that are involved in the project. So as Nick said, this project was born out of prior work we did in energy monitoring and manufacturing called Tempo. That was a cross-border project funded by Enterprise Ireland, looking at energy use in the manufacturing environment. So really looking at identification of energy use on the factory floor for large companies who all had a good handle on their incoming energy use and had implemented efficiencies, targeted efficiencies, the sort of low-hanging fruit, such as lighting and so on. But when it came to manufacturing on the factory floor, the energy use was essentially a black box, and they didn't know where that energy was being used, what was the significant energy users, and how to allocate that energy use against different processes or different product lines. So that was something they were really interested in, and we delved down through a sort of mixture of hardwired metered devices and also inferred energy then from the information that we gathered over short periods of time. So that was the Tempo project, and from that then we've looked at other projects. We've extended that with a proof of concept funding, and we've also been involved in the iCure program, looking to spin out this research into industry. And part of that led us to the Tenants project. So this was total energy monitoring in the dairying community. So as part of that project, again, it was funded by largely by Agri, who are R&D arm here in the agri-food sector in Northern Ireland. Dale Farm also contributed financially to that and had industry partners in the project. And we also had input from Ulster Farmers Union and Caffrey College here, as well as researchers here in UU. So the pilot essentially involved 6 dairy farms, a variety of different farms from both the traditional part and also robotic, and varying in size in terms of herd size. And this project ran over 2 phases. So the first phase was really in looking at energy monitoring, recording, visualizing, and identifying really the significant energy users on the farm. Phase 2, then we looked at of those farms and brought another farm onto the project that had on-site renewable generation. So looking at on-farm renewable, particularly solar and wind generation where it was available, and looking at how could best use and exploit that energy use on-site rather than sending that back to the grid. So the main problem that we were looking to address was the high energy cost for milk production. So high energy costs everywhere, but in terms of milk production, because there was such a fine margin of profitability, they were looking to try and maximize profits by reducing energy use and reducing the costs associated with producing milk on a daily basis. Another issue they had then was there was no real visibility into the on-farm energy use for each farm. The processes remained the same for dairying. The main energy users were heating of water to wash the tank and wash the parlour, the cooling of the milk from the cow to the tank until it was collected. So there's a large energy use there with cooling the milk to the desired temperature, and then vacuum pumping as well during the milking process to pump the milk around the farm. We also wanted to look at the best use of on-farm renewables and generation, as we said, and see how they could use those to maximum effect. But the reason the dairy sector are really interested in this approach is that, as we know, they're under significant pressure to reduce their CO2 emissions, and they really wanted to explore ways of doing that without impacting their operations significantly or without potentially reducing their herd size. So as you can see at the bottom, there's a large variation from the sample study we've done in terms of energy use for sort of average dairy herd farm sizes. It can range from 7,000 to 12,000 pounds. So there's a big difference between the best performing and worst performing farms. And the thing about the dairy sector, they're all very open to sharing their own ideas and sharing best practice with each other. They wanted to see, well, which farm has got the best method of cooling, which farm has the best method of heating water, and share that information, and so they can make informed decisions about investment on the farm with information from other farmers. So it was completely different than the manufacturing industry, where everything was secretive and closed. The dairy farming sector were very keen to share ideas and learn from each other. So that was good for our project. So the project itself, so this slide is a bit busy, but on the left, we've got a sort of system architecture. And we've developed this A-Tempo control hub, which is a mixture of hardware and software to both read in the information and then process and analyze and visualize that information in a sort of web interface. But the little red circles you see there are just simple CTE sensors that's monitoring energy consumption. So from the grid, the main incoming grid, we're monitoring energy use on the farm. And then within the farm, as I mentioned, we've highlighted the sort of three significant energy users, the hot water heating, the milk cooling, and the vacuum pumping. So they were all monitored on farm. And then if the farm had on farm renewables, so if it had PV or if it had wind turbines, that was measured as well. And anything else that the farmer was beyond that, farms have specific other niches and different bits of hardware. If there's something they wanted to monitor, we would do that as well. But the main things we're looking at was the main significant energy users. On the right, then we see some of the installations in the farm buildings where we had a lot of the CTs mounted on the distribution boards, and then that data was logged and sent via 4G dongles to a server, and we could then extract using API data, extract that information for the server and present it in a way that it was presentable to the farmers and they could understand, and it could also be seen by the other stakeholders such as Dale Farm. So if Dale Farm had a number of farms, they could see how each farm was performing against the other. Okay, and this just gives an idea of the sort of energy profiles of a number of those farms over a period of months. So this is a sort of collation of the three main energy users, and you can see a breakdown in that pie chart where they're fairly even, although the water heating takes up the larger percentage of energy use across the farm. So I said there were 6 farms, all of different type. The first farm in the bar chart there is robotic farm. It was the highest energy user because the milking process is operational 24/7. So the cows are constantly coming in to be milked. And so it is quite a high energy user, but obviously the big upside of that is you're reducing the manual labor needed to process or to milk the cows at different stages in the day. The other farms were traditional parlors, some were small, some slightly larger, and you can see the variation there in terms of energy use. The measurement we're looking at here, or the KPI was the kilowatt hours per 100 litres. So how much kilowatt hours is needed to produce 100 litres of milk for each farm. So it was a consistent measurement KPI across all farms. And just, I suppose, some of the things that we took out of the initial analysis of the data, and a lot of this was initially hand analysis through Excel and so on. But in terms of robotic farm, we identified an issue in late January, February, where the energy profile of the robotic system was increasing. And that manifested in a condenser issue within the robotic system. And once we identified that to the farmer, they could get the right service team out, the Lely service team out, and fix that issue. And you can see then in March and April, that is significantly reduced. So that's something that we'll talk about later on in terms of thresholding and identifying energy users and making the farmer aware of this by an alert process or an alert system. Some of the other issues we identified then for the smaller farms that were typically older farms, quite small herd size, they had a significant energy use in comparison to other farms. And a lot of that was because they didn't have any pre-cooling system installed. They didn't have any plate cooling system to chill the milk from the cow before it gets to the tank. So a lot of their cooling was done through the tank, and that was a significant energy user. And again, we could feed that information back to the farm and identify and show potential savings they could have by installing a plate cooling system and what that would cost. I suppose one of the other things then the best performing farm there on the right hand side was a larger farm, 250 cows, but it performed really well, and it largely was down to the fact that, well, firstly, the farm was 3-phase, so a lot of its motors and pumps and things were more efficient anyway, but it also had variable speed drive control on its vacuum pumps, which meant that it was that sort of investment in technology brought down its energy use considerably. So that was a good comparison for the other farms to see, so they could weigh up, well, in terms of my outlay and cost in purchasing a vac or a variable speed drive, how does that impact on my energy use and what is my return on investment on that? So we also, in phase 2, we looked at on-site renewable generation, and you can see here a profile. This is a daily profile of one of the farms that had a 5 kilowatt or 4 kilowatt solar system installed. You can see there from the left-hand side, during the night when these farms are all on economy 7 tariffs, they heat the water for both the wash out the tank and also to clean the parlour. The morning and evening milking periods there mainly use both the condenser to cool the milk and also the vacuum pumps to pump the milk around the farm. That large green area in the centre is really the solar generation, the energy generation that they have through the day. And what we can see from this, it's quite obvious that when they're generating energy during the day is when they're using least energy on the farm. So the obvious thing here would be to, I suppose, to time shift that energy use and use it either in the evening time during milking, or more specifically at night for the heating the water tank, because there's a similar profile there on this particular day. So again, the obvious solution there would be to put in some sort of battery storage system so they could shift that energy, store the energy during the day, or charge the battery during the day, and then use that stored energy to heat the water at night. But again, that come with another significant cost, and farmers were looking to outlay that cost as part of this project. So they're looking at other solutions and other options, take the existing systems that they had and try and maximize that energy generation. So with that in mind, we looked at optimizing the water heating strategy within the renewable. So using that energy profile to heat the water, we came up with a sort of controller algorithm and system to monitor both energy use, energy generation. So what has been currently generated by on-site wind or on-site solar, and use that to heat small elements of water. So depending on how much energy we had incoming from our renewable sources, we could heat a certain amount of water and control the water inlet valve just to heat the water through that day. So, which meant then when it came to nighttime, the temperature in the tank would have reached a certain threshold or a certain level, and it would take less energy to heat it to the 70 degrees that was needed, or 80 degrees that was needed for the washing process. So the rest of the slide just shows some information around a typical day. During the morning and afternoon, the average generation was 1.5 kilowatt hours. So it sort of totals up there at a total of 27 kilowatt hours generated by the solar, which could have been used to heat the water during that particular time, rather than use that or rather than sell that generated energy back to the grid at a reduced cost. It's better, more efficient to use that energy on site. So we've did some initial studies on this, and given a particular electricity tariff, there's a weekly saving to be had of around £22, which doesn't sound an awful lot, but over the course of a year, it's over £1,000 to a farmer who may be spending 7,000–8,000 on electricity use. So that is a significant reduction in their costs, and obviously increases their profitability. So this is just a view of the dashboard that we presented, a web interface that the farmers could log into and see their energy use across the different processes. They could drill down, and they could also look at their performance on the left-hand side there against the average. And that average was used then to provide, that could be 4-week or 8-week average, to provide a threshold for the farmers to say, for us to alert the farmer once it exceeded the threshold that there is an issue here, you need to go and find out what's the problem. You can also see the generation and consumption on the right-hand side, and also the daily water temperature chart to show. And there's also, it's not on this particular slide, but there's also a chart there to show the milk temperature. So the milk temperature is useful for Dale Farm to see the profile over a period of day, because obviously the longer the milk stays at a high temperature, then the reduced quality of the milk. So that was very useful for the producers themselves. So what that all affords in summary is we've got real-time insight into electricity consumption for the main energy users on a farm. It also highlights reduction approaches that we can see for the potential pre-cooling for using various speed drives, and allows farmers to compare against each other in terms of what their energy use is. It provides evidence for the on-farm renewables to show the benefits of having solar or wind or on-farm renewables and what can be done with that on-site generation. And it also opens a window for using automation, so using artificial intelligence to better analyze and provide interventions on the farm to take some of this decision making away from the farmer, or at least use AI to identify issues and use that as an alerting mechanism. Okay, so thank you. That's everything. Along the bottom there, you'll see the names of the people involved from all the different stakeholders. And that's one of the meetings we had. But thank you all for listening.
Thank you very much, Malachy. That's a very interesting account of energy usage around the farm. Certainly provoked a few questions in my mind. On questions, could you please put them into the QA, and we'll get to all the questions at the end for all the panelists. So I'll move on quickly to my next speaker here. And this is Jean-Nicolas Louis, Dr. Jean-Nicolas Louis from University of Oulu. And he's going to be talking on district heating systems and advances there in Finland. Jean-Nicolas is a postdoctoral research fellow at the University of Oulu in Finland in the Water, Energy and Environmental Research Unit. He received his PhD in 2016 from University of Oulu in Energy and Environmental Engineering, with his work on dynamic environmental indicators for energy system optimization. And his research interests lie in sustainability assessment, energy system and smart building modeling, especially optimization problems in the context of smart energy networks under climate change constraints. So without further ado, Jean-Nicolas, if you could load up your slides there, I'll give you the floor. Thank you.
Sorry, I think you're seeing my slide right now, right? Correct? Okay, excellent. Well, thank you very much for the introduction, and welcome everyone, and for these presentations of one of our EU projects called the Making City, which purpose is on developing positive energy districts across 2 main cities and 6 follower cities. One is in Oulu, and the other one is in Groningen in the Netherlands. So Oulu, that's where we are in the northern part of Finland, 65° north, and the network, or the city that has been considered, is this district in the southeast of the city center of Oulu. And the district that has been considered to be turned into a positive energy district is an existing district where you have the school that has been considered in, a supermarket, and 4 apartment buildings. So one is a private apartment buildings, and 3 of them are city-owned buildings. One on the left-hand side here in yellow is the a retrofitted building, and the 2 others are, or 3 others actually, are brand new buildings that they have built for this particular project. So they are the new buildings were made according to the latest regulations, and the renovated buildings also up to date. At the moment, the The supermarket is up and running and has been monitored for now about a year. And the school and the buildings are, some of them are still under construction, and some of them are already inhabited, and the monitoring process is going to start quite soon, actually. So the presentation today is about how we came up all the way to building up a positive energy district, and the start of the monitoring, and how did we set up the monitoring. We have to remember also that in the northern part of Finland, the design temperature is -32 degrees. So we have also to consider that the heating part is quite crucial in this area. This is a graphical representation of the area that we have built. On the left-hand side here, you have the supermarket and 2 buildings. In the back, you can see the district heating lines, where you have the inflow water from the district heating that is between 80 degrees to 120 degrees. And you have the return water from the district heating that is much lower, around 40 degrees. The particularity of this project is that each buildings have a heat pump system that is connected to the return water of the district heating system. So we consider it as a recovering waste energy that is going back to the power plant. And in that sense, it is considered as a free energy to the positive energy district. The supermarket, well, all of the buildings have PV panels on the roof, some with storage. The supermarket has a borehole storage systems with a heat pump. And the buildings also have a water tank, like large water tank with phase change material to increase flexibility in the buildings. So the overall target is to have the entire district as positive on a yearly basis. On the left-hand side here is the interface, that is the public interface that everyone can access to. And I will show you some examples after of what kind of data we can get out in real time from this positive energy district. So as I said, the energy consumption is measured at the building level, and we have all the data at the building level, and we are now implementing it at the resident level. So some apartments are going to be monitored more precisely. All of the monitoring process is done at the minute scale. So we are very detailed, or that was one of the targets, is to have very detailed information and measurements from each of the buildings and apartments. And one of the purposes that we want to develop control system and AI or machine learning control system for controlling the entire positive energy district. And the overall energy use is the imported district heating that we import into the bed area, which is a kind of a geographically constraint, the free heat from the return line, and then the waste heat for the heat source, for the heat pump system. We have also to remember that this positive energy district, it's not an islanded system, so it's fully connected to the network. And here we are balancing the energy production and the energy consumption to have a positive balance at the end of the year. One of the good things is that the district heating here is using mainly biomass, hydro, and then we have hydro and wind as the main source for electricity. So the environmental impact of the particular positive energy district that we have in Oulu is quite low. There is a virtual positive energy district from the point of view that in the calculations also we consider wind power that is produced outside of the boundary, the bed boundary, but that is owned by, for example, the building owners, like Agri is the supermarket that owns part of this production. Why monitoring? Well, on top of the projects to measure that what we do is actually what we are aiming for. Machine learning training, that's the most important for control purposes, and develop new control systems for maintenance purposes, but also flexibility purposes, short-term flexibility and daily flexibility and seasonal flexibility if we have storage. At the residential level, or each of those apartments that are going to be monitored starting next month, is mainly to increase the awareness to each tenant in terms of energy consumption in their houses, the cost associated to it, and the environmental impact. And what we are looking for also is to find out if end users are going to have different decision-making process if they get access to environmental impact data and cost data, and if they can make a decision or rational decision between a trade-off between the two, if this is a problem. These are some results that we have from the existing system. Here's the heat pump COP, coefficient of performance, that we have. Because we are using the return line from the district heating, which is about 40 degrees, we can actually reach quite high COP values, between 3.5 up to 5.5 COP, depending on the month of the year. Of course, the coldest month here, that was December, last December, we reached maybe -25, -30 outside. So that was one of, but still the COP of that heat pump was pretty high and delivered quite good heat. This is some data that we have from the PCM, from the phase change material that are in the water tank. So those are like small capsules that can change from liquid to solid. And on the left-hand side, you have the temperature profile of the water tank without those phase change material. So we heated it up to 60, 65, 70, 67 or 70 degrees, keeping the temperature, and then looking at what is the temperature loss of the water tank in time. And on the right-hand side, it's when we added the PCM, the phase change material, and we can see this kind of stair shape of the water tank temperature, where we can stabilize the temperature and increase the flexibility by about 100 minutes. So 1.5 hours of flexibility, extra flexibility that we can have by using phase change material. This is one of our biggest challenges was to try to cope with the GDPR. So the data protection, as we are monitoring 1 minute resolution data in every apartments where we have individual people. So we can actually get access to quite, lots of data. Here is the frame of data measured by VTT, which is the Technical Center of Finland, where they measure humidity, temperature, CO2, and power consumption. The power consumption is a plugged-in measurement device on the smart meter, and because the smart meter cannot access this low detailed information, but we can access them remotely by bypassing the smart meter. But the energy provider is involved in the project, so it's all done together. And the building owner measures also the airflow and the air pressure in the building, in each apartment. Only the water that was originally planned was in the end not included into the project. All those data are in servers within Finland, and then we have the data controller that either retrieve the data back to the end users or anonymize it for us to do research and developing model so that we can afterwards work on new control systems. So this is our framework for coping with the GDPR and how we handle this in this matter. This is the interface that the tenants have. In the middle, you have the data from the PED, Positive Energy District, data from the environmental impact, and the pricing also of the data. Up here is their interface. So the end users have a direct access to the power consumption, heat, what's the temperature inside the house, and the humidity, relative humidity in the building. And that's their historical profile. But they can also have access to this kind of clock where they have both information, where the inner circle is the information about future CO2 emission level, and in the outer circle is the price. So they can get an information about that the next hour is going to be green but expensive, but if I wait until eventually 11 or whatever time it is later, like we can match both the environmental, like low environmental impact and cheap, or expensive but high environmental impact, or any combination of those that we have. Data are retrieved every 3 minutes, but in this graph, this is on an aggregated 1 hour level. And of course, they can all access the data, and those data are generated directly by the project in our own servers, and then they have access to it directly. So what's coming next is that we have selected about 30 apartments where we are going to equip it actually about next week. Next week, we are going to have all the equipments deployed in all these apartments. And starting in May, we are going to start the measurement campaign for about a year until next year. And then from next year on, we will start to see what were the measures that were convincing to the tenants. Of course, we will have regular meetings with the tenants on how we can, or they can raise their own awareness and how they can be involved actively in contributing in making new positive energy districts in the north and in other following cities, because we are followed by different cities in Europe. So that was the project in short. Thank you very much. And if you have any questions, please, I'll be happy to answer them. We don't hear you, Nick. You're muted.
Sorry about that. Thank you very much, Jean-Nicolas. That was a very interesting account. I'm sure that will provoke a lot of questions. I see one there already. We'll get to it at the end. I just want to quickly go on, just conscious of time, and introduce our final speaker. And this is Shane Elliott from the Northern Ireland Housing Executive, who's going to talk about housing and health. So Shane is a qualified occupational therapist and works in a jointly funded post with the Northern Ireland Housing Executive and the Department of Health. And his role as a housing and health lead focuses on the promotion of collaborative working between the housing and health sectors to improve the accessibility of housing stock for people with disabilities, and also includes providing advice to the NIHE and the Department of Health, including input to and the development of relevant policy and strategy regarding housing and health interfaces. So thank you, Shane. I'll leave it up to you now. Thanks.
Thanks very much, Nick, for the introduction. And just to give you a pre-warning, my presentation won't be nearly as technical or scientific as Malachy's and JeanNicolas was, but I'm really going to focus primarily on the interface of housing and health, the importance of the collaboration piece, and to talk briefly about some of the pieces of work we're taking forward here in Northern Ireland that may be of interest. And really, from listening to the previous conversations, looking at how we can be more collaborative beyond, because primarily our focus on housing and health at the moment is about accessibilities of homes, but I think we need to extend the scope of that and look much beyond that. So just to start, I suppose we're trying to reshape the narrative around housing and health and make it more about a home as opposed to the house. And when we talk about a home, it's not just a dwelling place. It needs to be a place of comfort, shelter, safety, and warmth, which very much relates to today's agenda. And increasingly, it is becoming the main setting for our health throughout our lives. Certainly the strategic direction in Northern Ireland, as I'm sure it is elsewhere, is to move people as swiftly as we can out of acute care, keep them out of residential and nursing home care, and look after them in their own homes. And that's where the majority of health needs are now being met. But that's relatively meaningless if the house is cold, it's not safe, it's inaccessible, and people can't get to and from the rooms that they need to get access to. So it's very important that if we're going to take that strategic direction of providing care in the home, we need to make sure that the homes are actually suitable for the provision of that care. And certainly a lot of the problems that we would see are where that is not the case, and that has a knock-on effect to people's overall health and well-being, and not just their physical well-being, their emotional and mental well-being can be significantly impacted by poor housing. So when we look at that across the piece, when we talk about home and well-being, we're talking about the safety of the home, reducing falls, accidents. We're looking at people being as independent, having a good quality of life, having greater control over their lives, being able to develop those social relationships and that sense of belonging that we all have, their emotional well-being, financial well-being, been able to access employment and education, and we can see through COVID the importance of home in terms of people being able to work from their home, improving health outcomes, and there's plenty of research to back that up. Importantly, to reduce the need for hospital admissions, we certainly know in Northern Ireland that our hospital bed capacity falls below what the demand is, and every other week on the media, there's a crisis in a hospital in Northern Ireland where the beds are, the A&E is blocked up because they haven't beds to move people through. So it is important that if we're going to move people or keep people out of hospital, and we're going to move them through the hospital setting, then we need to be moving them to suitable environments, and also to try and reduce the need for nursing and residential care. Again, the evidence would very clearly show that people want to remain and be cared for in their own home and until their last days. So we want to try and reduce the need for that need for residential care. The government have already developed white papers on this, which makes it very clear that healthy homes and buildings contribute to, a lower cost to the NHS and healthier populations, better educational attainment and workplace productivity, reduced emissions, lower energy bills, and lower carbon footprint, which is probably of interest to the subject today, improved health, well-being and comfort, and greater life chances, independent living and care. So that comes from the government white paper dating back to 2018. And the cost of unhealthy homes is very evident. And I think we constantly hear in the media now about the fuel poverty crisis and the need for people to choose between heating and health, or heat or eat. What's not really coming out in that narrative that I can see is that the impact of not heating homes and not having warm homes is very detrimental to people's health. And there's a plethora of research and evidence out there to back that up. That statistic, a startling statistic from 2014 and 15, showed that there were nearly 44,000 excess winter deaths according to England and Wales. And the impact of cold housing was estimated to cause a fifth of those excess deaths. That's the government's own figures. It shows that children in cold homes are more than twice as likely to suffer a respiratory problem than those living in warm homes, and that more 1 in 5 adolescents living in cold homes are at risk of multiple mental health problems compared to 1 in 20 in warm homes. That's not coming out in the fuel poverty narrative that I'm hearing. And I think in the Department of Health, with my foot in that camp, we need to really get that front and center much more, that it's if the fuel poverty crisis continues into next winter, we're likely to see the impact of that on our health services from the evidence that already exists. And cold homes are associated, probably doesn't come as any surprise to anyone, with increased incidence of colds and flu, which do kill people and are known to worsen existing conditions like arthritis and rheumatism. If you've any aches and pains, how they're exacerbated by the temperature. So there is a real need for us strategically to look beyond purely accessibility of housing and extend that into looking at how are they heated, how energy efficient are their homes, how safe are they for people to manage and be cared for. This is a graphic from the World Health Organization that I like, that I think covers off a lot of that. As you can see, it talks about a healthy home being accessible, well insulated, good stable indoor temperature, free of hazards, reduced noise, lack of indoor pollution, not overcrowded, protected from toxic materials, good water, sanitation and hygiene. So there's a whole lot goes into what makes a healthy home beyond what our focus has been, and certainly in my role, the focus has been more around the accessibility of the home than a lot of these other areas. And we probably do need to get better at joining the dots on that. So what we're trying to drive is strategically is much more of a focus on integration and looking at partnership working between the relevant players in the health and social care field. So you've got the health services, obviously, social care services. There's a major reform of social care services going on in Northern Ireland at the moment. We need to look at the housing piece and the assistive technology, be that community equipment, be that technologies to enable people to manage their environment, be that telecare type technology. And I think if we don't join up all of those areas, they're going to have an impact. We can make people well through surgery and medication. We can put domiciliary care in to support them in the home environment. But if the home's not accessible and they haven't access to the right kit technology to manage their care, then very often they can be existing, not living. And I know of plenty of examples where people are being cared for and looked after in their living rooms with a commode beside the bed. You know, so that's not active living. That really is existing. So we need to get better at joining up those strands if we're truly trying to promote independence and quality of life. So what have I said? The current focus, a lot of it has been on accessibility. And when I say accessibility, I'm talking about physical access to, from, and within the home. So looking at level approaches, doors and corridor widths, space standards in habitable rooms. And that is facilitated in Northern Ireland through an adaptations programme. There was 29 million spent in that last year. And new build programmes, where we're aiming now for 10% of new build social housing to be built to wheelchair standard. And the executive, alongside the associations, are working towards that target. The challenges in that, and are many, both on the housing and health side, and I can see it with a foot in both camps. Resources are finite, and we're certainly hearing doom and gloom this year in terms of what is going to be available financially. So that doesn't sit well with the increasing demand. The population is getting older. People are living longer. As a consequence of living longer, they tend to live longer with disabilities, the comorbidities associated with old age, and the impact on how people can do things for themselves. Access to suitable properties. There's not the accessible housing stock doesn't meet them but demand. So there's significant waiting lists on both the housing and health side for assessment and provision. Processes are complex, and we need to get better at working across the interfaces to improve that. And the timeframes for delivery aren't really what we would like them to be. So there are many challenges. Some of the key work streams then that we are taking forward, we've reformed the departmental forum. It's called the Interdepartmental Housing and Health Adaptations Programme Board. And that's really where the Department of Health and the Department for Communities come together on a regular basis to address and look at how we can work better, what our strategy and policy going forward needs to look like. I personally think we need to look at extending the scope of that forum beyond purely adaptations, and we need to align ourselves more with energy efficiency, warmth, and the standard of the housing stock, as well as the accessibility of the stock. So that's a work in progress. We've started to undertake a regional review of assistive technology services. So we're looking across Northern Ireland at how these services are currently delivered, with the view that we'll make a number of recommendations as to how we feel they could be improved across the region. And part of that review is looking at environmental control systems, which are really systems that enable people to control functions within their environment, like their lights, their heating, their television, et cetera, to improve their independence. So that's a work in progress. We're looking at input into the relevant strategies to ensure housing is referenced and embedded in those strategies. And examples of that are the social care reform. There's an autism strategy being developed. There's intermediate care strategy underway at the moment. And we need to ensure that housing is embedded, and the need for good, safe, warm, accessible housing is embedded in those strategies. We're updating best practice guidance in terms of access to housing adaptations, who's actually eligible. We're reviewing our adaptations design communications toolkit, which really lays out what our design standards are. And those are primarily mobility standards in terms of what size rooms need to be to accommodate the needs of someone with a disability and the needs of their carers. We're developing an inclusive design guide. It's a work in progress, but the working title is Housing Design to Support Independent Living. And part of that will be focusing in on the sort of ventilation, the heating, the energy efficiency, of the buildings, etc. And it's really with the focus on those people with cognitive and sensory impairment, because we've done a lot of work in terms of mobility impairment and people with wheelchair needs, but we do need to get better at the hidden disabilities, those people with autism spectrum disorder or learning disability, who it may not be obvious of disabilities, but the environment can have a significant impact on their ability to function. We're developing complex case management guidance where we will look at interfaces between health and housing, and introducing partnership forums where housing and health will sit down together on a more regular basis to look at how we can improve things. We're developing an accessible housing register, because at the moment our intelligence on where our accessible housing stock is not what we would need it to be. So we've developed an accessible housing register, which we're in the midst of starting to populate, that will actually enable us to know that if a property becomes available, that it will have an accessible housing scale, that we will know then, and we can match the right person to the right property. We're introducing training for frontline staff particularly around autism, developing clearer pathways for people with disabilities, because someone with a disability fronting up to the housing executive or looking for a property, it can be quite difficult to understand what they're navigating or how they navigate that. So we're trying to clarify those processes. We've developed some guidance with building control around minor adaptations. We're taking forward some research around the outcomes and effectiveness of housing adaptations. We're hoping the proposals in place, we're hoping to take that forward sometime later in the year. And I suppose just to finish off, because I'm mindful of time, is that we are really keen to look at the development of a housing and health strategy for Northern Ireland, and that will be all encompassing in terms of what the content of that strategy would be. The two departments are certainly interested. We just need to look at what would be required to resource that and how we would take that forward. So that's a bit of a whistle-stop tour, Nick, and I'm hoping it does fit with some elements of the work that Heater, and I think there will be a need for us to be more joined up with some of the work that's going on in terms of that sustainability and energy efficiency that I know Robert Clemens and the housing executives involved in. So,
yeah, thank you very much, Shane. I think it's right smack in the middle of what we're talking about here. You know, so you've just listed a huge challenge there, really, with I think all the old housing stock and whatnot. So we have about 7 minutes left, and I'd like to get through some questions. I see you have a couple of questions on the Q&A. I'd like to go back to Malachy. First of all, question for Malachy, really on the dairy farming energy issue. Basically, what are the next steps, Malachy, for your project, or where do you see this work going? And also, have you considered farms have plenty of space, plenty of land? Is there an option for farms to be completely energy sustainable with their own, you know, because they've got room for solar panels, they've got room for wind turbines and other energy storage. And just on the end of that, is it feasible? You know, can they get their money back if they invest in that, you know?
Yeah, well, a lot of that depends on the farm and the area and the type of land that they have. You know, a lot of farms that are in, I suppose, very good arable land probably wouldn't see that as of benefit, but farms that are maybe more mountainous or poorer ground, then they do see the advantage of using part of that ground for installation of wind turbines or larger solar type farms. And you know, a lot of the large solar farms that are being put up in rural communities now are being housed on rural farms, and the farmers themselves are making an income from that rental of their ground, and also they're getting a percentage of what's generated. So there is some scope for that. In terms of what we want to go with, or where we want to go next, is we want to take this from isolation. So every farm's a silo, and it's got their own potentially storage facility, it's got their own generation, if it's solar or PV. So they are a small little islanded power plant, if you like. They've got generation and they've got storage. So, but to the suppliers, to the likes of the Energia or the Power NA, you know, they're a very small player. But what we're looking to do is aggregate a number of farms. So because they're all very similar in makeup, they've got similar energy use, they've got similar storage capability, they've got similar on-site generation. If we aggregate a number of farms together, so instead of taking one farm, we aggregate 50 or 100 farm, now they become a bigger player, so they can use their demand, so use their demand for heating water or for making ice as essentially to help demand response on the grid. So it can be used when there's excess energy on the grid, they can be used as a load essentially to take some energy and make ice or heat water. And they could be used for curtailment as well and wind energy. So that's really where we want to take this, rather than just have them in isolation, aggregate them all together in larger sort of virtual power plants that they can help the grid essentially and local to their communities.
Thanks very much, Malachy. Yeah, that's very interesting. I'm just going to rush on here, get through some of these questions on the Q&A here. This is a question from Jean-Nicolas from Stephen McGonigal. Was there a recommended minimum data items to be monitored or collected as part of the project to deliver against objectives?
Yeah, I was just having a look now that what we had a dedicated deliverable on the KPIs and what do we need to monitor. And for each city that we have 22 KPIs that goes from energy monitoring to unemployment. So we have mobility characterization, energy and environmental impact, and governance and society. So we have about 22. If we speak only about energy monitoring, the constraint was only to be able to answer to this KPI of do we have a positive energy district by the end of the year. So it's mainly about incoming energy coming into the positive energy district boundary and consumption in the building. But we went much further than that because the supermarket has about 1,000 measuring points, and then all of the residential buildings have one main point of measurements, and then the apartments have about 7 of them. But those are kind of beyond the project objective as such. So we didn't have so much constraint about the number of items.
And there was a question there from Fatima Sarah from Jean-Nicolas too as well. I joined late. Who are the end users? So quickly, is this the apartment owners or apartment? Yeah.
So there is one private building, so they are private owners, and the others are 3 public, city-owned buildings, so they are all tenants, and the owner is the city of Oulu. But all of those end users are either rental or private homes.
And a couple of questions on heat storage. One from me. I noticed that there was in your diagram, was there borehole energy storage there?
Yes.
On that site, that project, how does that work?
The borehole is connected to the supermarket, and they are storing the energy under the supermarket area, and they are tapping into it when trying to balance between the energy that comes from the district heating and the energy that is available in the borehole. But if you want more details, maybe I can connect you actually with the project coordinator who has actually worked specifically on that, because I am more into the residential part.
Yeah, no, it's just that on our Smart Renew project, one of our partners in the Faroe Islands was experimenting with borehole storage. Okay. And storing water in the borehole as an experiment, you know. And I was just curious when I saw that. I have another question for you from Andy Frew. How you doing, Andy? As large-scale heat storage underground or in big hot water tanks a useful role in decarbonizing heat using wind energy for heat?
At the moment, the wind capacity in Finland is quite low compared to what we can have in Ireland or in the UK in general. So it's not comparable, but yeah, definitely. So what we have in thermal storage with the phase change material is to be able to have this flexibility of 1 hour, 1 hour and a half. So that definitely increases the wind power utilization, because what the whole point of this intermittency of wind power is that it's at the minute based. So definitely this heat storage can contribute quite greatly if we want to have direct electrification of the heat. Yes.
That's great, Jean-Nicolas. There was a question there for from Richard Boyd, but I think Robert's nipped in and answered it. But I might, I'll just read it out again, and just for the audience there, with the executive support. This is for Shane. With the executive support of Home Health, what metrics are being monitored, or would you like in place? We are working in the Roulette project to support the monitoring of CO2, temperature, and humidity. And these devices are getting cheaper, more accessible, and are being integrated into home automation visualization. So I suppose he's asking what metrics are being monitored, or what would you like in place?
I'd be perfectly honest with you, Nick. I don't know. I think that's a conversation. I think that's a conversation that needs to be had in terms of what metrics do we need to be looking at? Because primarily, as I say, my focus and my role was intentionally to look at accessibility of homes. But I really do think there's a need to extend beyond that to start to look at the healthiness of the home. So I would be open to conversations in terms of what those metrics would be. I think there is a need for probably more localized research in Northern Ireland in terms of the impact of fuel poverty on health and outcomes. So there's a piece of work that I think we need to be to do there. I think there's also a lack of understanding in the general population, particularly the older population, in terms of how they can efficiently heat their homes. Because at the moment, I think they're choosing not to for fear of the financial impact of that. So I also think there's an education and awareness program that needs to be rolled out to make the connection. If you're not heating your home, you need to understand it could actually have an impact on your health. And I'm not sure we've fully seen that impact at this stage, but if it continues the way it is, I would imagine by next winter we'll start to see that. Absolutely, I would have little doubt of that.
Definitely, you know, it's the problems you described there require a huge multi-agency solution, I think, you know, and especially with our old housing stock, the social and private. You know, at the minute in Northern Ireland, there's very little money available to transfer your old fossil fuel heating, you know, to help you transfer to anything renewable at the moment. So, and also thermally insulate these old homes, you know. So it's a big challenge. Okay, I just see we're just sort of running. We're just past our time here, and I promised to finish at 2 on the dot. So it's just past that. So I'd like to thank our speakers very much indeed. I think it's been a very interesting session this afternoon with great scope. And I'd just like to bring up a couple of issues. This is the second in our webinar series. We're having our third webinar in the last week in May. So we'll be sending out information on that as well. And then we have a closing conference, which will be a live hybrid conference in Finland, in Oulu, on June 22nd. So keep your eyes and ears pinned open for information on that. So without further ado, I'd like to thank you all for attending this afternoon. Thank our speakers again. And till next time, we'll see you again. Thanks very much. Bye-bye.
Thanks, folks. Thank you.
Thank you. Bye-bye.